Question number 35. In a Compton scattering experiment, a photon of wavelength lambda naught and frequency f naught interacts with an electron. After the interaction, the wavelength and frequency of the photon are lambda and f. What are lambda by lambda 0 and lambda f divided by lambda into f0? Okay, now let us address the first one here. Now, what is Compton scattering? Compton scattering. What does it reveal to us? It tells you that you have a photon of energy hf. It starts moving, which is moving with the velocity of light. It goes and hits an electron. It's a collision basically, and as a result of this, the electron moves in one direction and the recoiled photon moves the other direction. So why should this electron move? Because this is now giving some energy, right? It's giving some energy, so this moves with an energy momentum mv, and this has a lesser energy. If f is the frequency here, this will have a lesser energy, which is hf dash over here. Why hf dash? Because this has a different frequency and different energy, and definitely you can see hf dash would be less than hf. If hf dash is less than hf, this h and f, h can be cancelled. F dash is less than f. Or in other words, we know f can be written as c by lambda, right? C by lambda dash is less than c by lambda. Okay. So now what is c here? Velocity of light. So I can cancel these two here. And I can now write this as 1 by lambda dash is less than 1 by lambda. So what does it tell you? If this is the case, based on inequalities, we can say lambda dash is greater than lambda, or lambda dash divided by lambda is greater than 1. Now let us go back to this. It says lambda dash, this is your lambda dash over here, divided by lambda. Here lambda is called as lambda naught over here. So this should be greater than 1. So these two are right and these two are incorrect. Now let us look at this one here, lambda into f. What is lambda into f? We know that v is equal to f lambda. What is v equal to f lambda? Velocity of the any entity. So therefore over here it's a wave. So this is an electromagnetic wave. So the hf here is an electromagnetic wave with a very higher energy, and when it comes over here, this energy of this photon is much lesser. But what is the speed of this one? This speed is also c. This speed is also c. Okay, it is not getting into a different medium. It is only hitting something and thereby it's reduced energy. So therefore what happens is f into lambda is nothing but f lambda divided by f0 lambda 0. So f lambda is velocity of light. f0 with lambda 0 is also velocity of light. The speed of the photon can be reduced only in case of a refraction. When it is inside a glass slab or water slab, or it is entering into a medium of different refractive index, only then the speed of a photon can be reduced. Otherwise you cannot reduce it. So what's happening over here? The energy of the photon is being reducing over here. The energy doesn't mean the speed is reducing. Why? Because this could be true in case of the other cases. In case of other case, what happens is energy is given by half mv square. Here the energy of the photon is not given by half mv square. It is given by h into f over here. Okay. So therefore it does not involve your velocity over here. Velocity of the photon remains a constant if the medium is one and the same. So therefore this value is also c, this value is also c. This cancels and this should be equal to 1. So amongst these two, this is the right answer. So the answer A is the right answer.